Okay, so in this set, we will look at the limits of exponential and logarithmic functions. Okay, so in general, exponential expressions are, or equations or functions are expressed as y equals a to the x. Okay, and there are different variations. You can have the basic forms 2 raised to x. It could be y equals 3 raised to x minus 3. The x is no longer just x, but you have a minus 3. And it could even become 4x plus 1, and there's say a number minus 3. Okay, so these are examples of exponential functions. And it's not limited to numbers bigger than 1 when it comes to the base. Sometimes there are also exponential functions with fractional base, so 1/2 to the x. Okay, so how is knowing this type of functions will help us easily find the limit? Okay, so if we take a look at the first item, it's letter A. We want to find the limit as x approaches positive infinity of 3 to the x. Okay? If we will apply the substitution, just the shortcut or the fastest way to do it is we think of a very large number, we place it to the x, and what will you expect with the 3 raised to a very large number? Diba kunwari, infinity, 3 to the infinity. Increase siya, very large. Diba? So, even with that technique, you can already conclude that it will take you, or the function will be to positive infinity. Okay, but let's put it in context. Why is that substitution technique work or will work in this function? I always use the idea that we should know what is the graph of 3 to the x, so that you can have a view, like a concrete idea. Why is it positive infinity? The graph of 3 to the x, based from the lesson on exponential, will pass through a point on the y-axis, and this will go in this way. Okay, if you go to the left, negative infinity, the x-axis will be a horizontal asymptote, meaning to say the graph is approaching 0. If you go to the right, to positive infinity, then the graph is moving up to positive infinity. So make the x larger and larger and larger, then the x goes up to positive infinity. That is why the answer is positive infinity. Okay, so let's not move to b yet, but let's expand the idea. Suppose I change it to negative infinity. Find the limit as x approaches negative infinity of the same function 3 to the x. If we do substitution, sometimes it's confusing, like 3 to the negative infinity. What is really happening if we place negative infinity on the x? But if we try to view it in the graph, if you go to negative infinity, what is happening to your graph? It is approaching a certain number, and that is based on the horizontal asymptote. The horizontal asymptote is y equal to 0. So you go to the left, negative infinity, then this will be 0. The limit will be 0. Right? If I place 3 negative infinity, you might think the answer is negative infinity, which is wrong. Okay? So sometimes yung mga shortcut, instead of helping you, it could even confuse you. So go back to the graph. Okay? And then immediately in B, so I selected the one with a fractional base so that you can connect what if it is the other case. 1 over 3 raised to x. The only thing that you need to know is what is the graph, to know the graph of 1 over 3 raised to x. So this will be exactly the opposite of item A. Okay, the 3 to the x. So as we go to positive infinity, we are now approaching, or the function is now approaching a specific number, and that is 0. So you will not be confused. If I change it to negative infinity, by viewing the graph, you will know that it's going to positive infinity and not even negative infinity. Okay, so you need to be familiar with the graph of a to the x, where a is a number bigger than 1, and then when the number is smaller than 1 but greater than 0, or fractional basis. Okay, questions? And then sometimes the base is not a whole number or a fraction like 1/3. You might encounter limit as x approaches positive infinity of e to the x. Okay, but actually e to the x is just a special case of a to the x. Okay, what do we know about the number e? Its value approximately. It's not 1 point something. 2 point something yun, tama? Okay, so it's a 2 point some value to raise to x. Now we can place it to either cases. Is it the case 1, yung first example, or the second case? The first, right? Because it's 2 higher than 1. So the graph will tend to go up to the right, but to the left it's approaching 0. Same pa rin. Okay, it's still the same. So if I say, what is the limit as x approaches positive infinity, then the limit is also positive infinity. Mas madali na siya. Okay, positive infinity. And then what about for the log? So limit as x approaches 0, log of 0.5, log base 0.5 x, or log x base 0.5. So same idea, we all go back to the graph of a log. Like a to the x, the base could be a number bigger than 1, or it could be a fraction less than 1 but bigger than 0. So this is 0.5. This is equivalent to log, this expression is equal to log 1/2 and then x. Okay, let us talk about first what if the base is bigger than 1. So say log base 2 of x. Okay, the graph of this will be intersecting a point on the x-axis. To be exact, that's 1, and it will go up in this flow or curve, and then down. Okay, it will go to negative infinity. Okay, however, if you have log, say a half of x, it's already a fraction less than 1, it will be the opposite. Okay, so the graph will be in this way. Okay, na reverse lang. Okay, now whenever we look for a limit, we just remember the graphs. Log 1/2 x as x approaches 0. Looking at the blue graph, approaching x equal to 0 means you go closer to the origin. As we go closer to the origin, papunta dyan, what is happening to our graph? The blue one. Going up, diba? Going up siya. And this means going to positive infinity. Okay, so the answer for the first one is equal to positive infinity. Okay, so this is equal to positive infinity. Again, I can change the question and make it as x approaches, say, positive infinity. What if I change the question into log still 1/2 x, but the limit I want to approach is x approaches positive infinity. Not 0. The blue graph. Ito na siya. Papunta dun. Negative infinity. Diba yung habang papa-right, the graph is going down infinitely. Okay, to negative infinity. So the answer is negative infinity. Okay. Next. Letter E. Limit as x approaches 0, ln x. So ln is still logarithms. But what kind of logarithmic function is this in terms of the base? Is it bigger than 1 or less than 1? Ano ba ang base ng log kapag sinabing ln? The base is e. Diba? So limit as x approaches 0, log base e x. But what is e? 2 point something. So ang labas niya, if we are going to select between the blue and the green one, the graph will be following the green. Okay, so as the function as x approaches 0, what is happening to the graph? Approaching 0 from the right. Anong nangyayari sa graph? Going down, negative infinity. Diba? So it's easier now to identify the limits once you understand the graph of the function. So the limit must be negative infinity. You don't even need to memorize. Okay? Well, you have to memorize the graph, or at least trace the graph before you evaluate the limit.